Hi again, this is part 2 of our mini course on building AI agents and RAG systems without writing code. If you haven't watched the first video yet, I recommend you going back and starting there. But if you already know what an LLM is and how to connect it to your app, welcome to the next level. In this video, we'll cover what RAG is, why it matters, and how it makes your AI assistant actually useful and safe. In the last video, we saw that LLMs are powerful tools. They can write text, generate code, summarize documents, but they have a serious limitation. They can hallucinate, confidently invent things that aren't true. Why? Because an LLM doesn't really know what is correct. It doesn't look things up, it just continues text based on probabilities. Now imagine your assistant tells a customer the return window is 60 days, when your actual policy says 14 days. That's not just a bug, that's a business liability. To solve this problem, we use something called RAG, Retrieval-Augmented Generation. It's a layer on top of an LLM that lets your AI pull in external data, the data that you give it. Let's go back to our black box analogy. LLMs are great in generating responses, but they don't know what's true. So let's say I have a stack of books. That is my knowledge base: instructions, documents, meeting transcripts, chat logs, FAQs, everything my business knows. Here is how RAG works. Step 1. User asks a question, let's say, how do I return a product? Out of the whole stack of books, the system picks 2 or 3 that are most relevant. It's like I say, here, read these books and these chapters, they are about returns. Step 3. We feed that content into the black box as a part of the prompt. Then we say, here's the context, here's the question, now give me a solid, accurate answer. That is RAG. We don't retrain the model, we just give the right data at the right time. So, how does this actually work? RAG systems usually use vector search, a type of a semantic search. Instead of looking for exact words, we search based on meaning. Here's how. We convert each piece of text into a vector, a point in multi-dimensional space. If 2 vectors are close together, that means the texts are similar in meaning. This process is called embedding. You end up with a list of numbers, coordinates of the vector. For example, let's say we have 3 pieces of text: herring, something that swims in the ocean, and giraffe. When we turn them into vectors, the first 2 will land close together because they are related. The third one, giraffe, will land way off the side. At least voluntarily, it does not swim. That is how we can find relevant knowledge even if the user phrases the question differently. Before we can embed anything, we need to get it to the raw text. Your data might live in PDFs, call recordings, CRM systems, Google Docs, wherever. All of that needs to be converted to plain text. How you do that is an engineering task. It depends on your format, on your tools, your context. You can use converters or parsers, human help, or even another LLM, especially if you need to clean or structure messy content. What matters is the output should be clean, readable text. If you feed in broken formatting or wrong content, the results will be just as bad. In the RAG world, there is a saying, trash in, trash out. If you give it garbage, you'll get beautifully worded garbage in return. Once you've got clean text, you can turn it into vectors. Simple as that. In this lesson, we're keeping it simple. We won't split the text into chunks, we'll just embed it as is. That's good enough for a basic assistant. How to properly split large documents into meaningful chunks, we'll cover that in part 3. What matters now is the basic flow. turn text into vector, store the vector in the database, later match user questions to these vectors and add that context into the prompt before calling the LLM. Alright, enough theory, let's build a RAG system on Directual. It will have two main parts. Part 1, the knowledge base, will upload documents, extract text and vectorize it, and part 2, the AI assistant, will be able to chat with it, it will remember the dialog context and search relevant documents using vector search. Note, we are skipping over some technical setup details in this video, things like building the database, UI and scenarios. You'll find all of that in the Directual 101 course. The link is in the description. So, once again, we go to directual.com, log into our account and create a new empty app. I'll deploy it using the Pro Plan trial, just $1 for the first month. Now, let's immediately add the new user we'll be working under to the database. We go to the system structure app users and add, just a reminder, the ID is the user's login and the password is stored in encrypted form. Let's start with the first part, uploading and processing documents. The platform has a built-in file storage and we are going to use it. We'll also create a reference structure for file types, audio recording, PDF or plain text. That's enough for now. Let's create a structure called data lake, where we'll store all information about files including vector representations. We create a knowledge base page with a form for uploading and a catalog of added files. Let's group them by type. Also, for each type we can add a counter of uploaded files. By the way, this time let's edit not only the menu in the web app settings, but also the color scheme. For example, I like the dark one. We can change fonts and right here make a logo from the catalog. Looks great, let's get back to configuring the form through which we upload files to the data lake. The first field, a reference list where we choose the type of file to upload. If it's audio or PDF, we show the file upload field. If it's text, we show a text input field. We'll use conditional field display for that. And the submit button will be inactive until the required fields are filled. This is how it works. Perfect. Now we set up the scenario. We don't need any synchronous logic here, just upload and go. First step, just in case we check if the file has already been processed. Just a simple isProcessed flag. Then we branch file type, audio, PDF or text. Text is the simplest, no parsing needed, we already have the text to vectorize. Let's start with that. We go to the marketplace, install the vector search and embedding plugin. In the data lake structure we add a field type of tensor. In the scenario, we add a step, fill in this field. Convert text to vector, that's easy, literally 2 clicks. Let's test it right away, run the scenario for new objects. We create a text type object. Check it in the scenario logs, great. This big array of numbers is the vector representation of our text. Next, for audio and PDF we need parsers to turn them into text. There are many such services including from OpenAI. Just Google PDF to text API and you'll see many, paid, free, etc. The job of the engineer configuring RAG is to select the right service or combination of services and call them using the HTTP request step. In our demo, we'll go the simplest, although more expensive route. We'll use OpenAI services to convert both audio and PDF into text. They're included in the plugin as separate steps. Let's try uploading, say, a podcast snippet. It might resemble a meeting recording, a typical business case. Okay, we have a text, but it's not a transcript. What do? Ask the LLM to clean it up. For example, format this as a meeting transcript with participant names. Now that's more like it. Same for the document. As the second step, we ask the LLM to format the text and output Markdown. Now it's readable, meaningful text. Of course, this pipeline should be tested on your own data. Maybe use different parsers, their combinations, add a mechanism for selective manual checks, and so on. But in any case, we vectorize the resulting text. And finally, we update the document counters by type. We do this with a separate scenario that works with the type structure and uses a search step to count documents of that type. Let's make the final touch. Create a subpage for document types. We add a parameter in the main page settings. On the subpage, we can add, for example, a table. But we need something to display in the row, some short title that the file is about. Let's add another LLM call to our scenario, generate 3 to 4 word summary title. Now it's great, very convenient. That's it, the first part of our RAG system prototype, the knowledge base, is ready. Next up, the assistant. From the marketplace, we install the Messenger plugin. We create data structures for our Messenger: chats, messages, actions, and intermediate structure for chat actions. We create an AI assistant page. It will include Messenger component and a socket for real-time chat updates. Our Messenger is connected to 3 endpoints, 2 for reading, GET requests, user chats, and messages from a specific chat. We add a filter on the endpoint. And 1 for writing, post requests, chat actions. Through this same endpoint, new messages will be created. We configure the chat's appearance and immediately set up 3 actions: create message, this one is required, delete chat, and create chat with the chatbot, our AI assistant. The interface is ready. Now let's move to the Messenger's scenario logic. We create an object that has a field action. It has value: send message, delete message, or new chat. For new message, we create an object in a step, fill its fields, write the chat update date for proper sorting, and update the interface via socket. For new chat, it's similar. We create a chat, but at the end of the scenario we use the API response step, so the messenger selects the new chat as active. For this, scenario must run synchronously. We remove its triggers and connect it to the endpoint for synchronous execution. Chat deletion we set is hidden flag, by which we filter chat objects at the endpoint and reset the current chat to empty. Nice, everything works, but the bot doesn't respond yet. Let's create a scenario that reacts to new user messages. Important: don't forget to enable event generation in the object creation step in the previous scenario. Okay, a message comes in. The first step: we collect all previous messages for this chat. Here is an interesting trick. We call the chat endpoint directly from the scenario and get a JSON array of messages. Let's test in debug mode. Call the endpoint and get this response. Now we need to transform it into a messages array in the ChatGPT API format. Easiest is to ask ChatGPT directly for a JavaScript expression to convert it, optionally using Ladash. Okay, we added data transformation step. By the way, to apply arrow functions in Directual scenario, we need to enable new JavaScript engine in the start step settings. Also, to save the array into the JSON field correctly, we must wrap it with the JSON stringify function. Then the next step sends the expanded prompt to ChatGPT. We get response, create a message, and update the interface via socket. Let's test it out. Hello GPT, my name is Pavel. What is my name? Perfect. The LLM sees the full context. Now let's add knowledge base search. Let's set this up in a separate scenario, which we'll call using the links scenario step. Before that, let's add a few documents to our knowledge base, say texts on sales and marketing. Connect the rec scenario to our existing one. We can pass the chat history as a context to the link scenario step. First stage, vector search. Tensor field, we specify the structure and its field with the embedding. Then, the user request. Nearest neighbor, how many closest vectors we search. Hits, how many we return. Let's set it to 2, for example. These parameters can be finely tuned. Let's test the step in debug mode. We see the vector search returned objects. We need to extract their IDs. Here they are. We can do this with a simple JavaScript expression. Save the IDs, comma separated, into an array link field. Use the template engine to assemble our context. Just in case, we can do re-ranking for our context, remove anything irrelevant if found. Let's do that with a separate ChatGPT request. Now we make the actual LLM query with question and context. In the messenger component, you can add any HTML under a message. Let's add our documents with the links to the respective knowledge base objects. To generate simple HTML like that, I personally use ChatGPT. We put together the HTML and CSS can go in the custom code section of the web app settings. So, we send the message to the chat, update it via socket and test. Ask our AI assistant. Cool, we see the answer and the related documents. Our simple RAG works. Of course, there is still huge room for improvement, but the basic features are done. Cool, Today we learned why RAG is important, how it helps avoid hallucinations, how LLMs go from chatterboxes to useful assistants, what embeddings and vector search are, how to prep your data to make it all work. And next, things get serious. In part 3, we'll dive into the advanced stuff, how to chunk documents properly, how to use structured output, how to apply chain of thoughts and log probes, and even how to run an LLM locally on your own machine. If you want to build AI assistants that are ready for production, you don't want to miss the next video, so see you there.